I'm Patrick Bailey with IQList. Today is June 11th, 2022, and in this video I'm going to show off the double-sized T-Rex skull done using a 0.8 millimeter nozzle with a 0.4 layer height. Okay, so here is the double-sized T-Rex skull at 0.8, and so you can see, of course, it's not gonna have all as much nice details as the 0.4 nozzle with a 0.15 height. This is a 0.8 nozzle with a 0.4 height. I think it's still pretty effective. Now, the nice thing is, and we'll go over the numbers here, is it's going to print out a lot faster. But also, as I'm finding out, unless you lower the infill, it's actually heavier. So we'll talk about that too. So therefore, it's going to cost you more in material, less in time, unless you go back and change the infill. And also, it worked out pretty well. I need to do some, regular cleanup on this. But I do have a couple of parts right here where it's not nearly as nice, right there, and on the other side there. I need to go clean up, and that could probably be solved by putting support there, possibly. I haven't tried that yet. I'm putting another one out without support. We'll see how it goes. Maybe after the show I'll try to do another support one and see how it goes. But we're trying to get these out. I'm trying to make these faster. Now, personally, for my thought process, I definitely like this one. Has more detail. You can kind of see that. I would just do the 0.4 nozzle with the 0.15, and I think it turns out great, because if you're doing it for yourself, you got the time. But if you need to make more quickly, this is it's not too bad. We'll see how people take it. But also, for us doing the homeschool show here soon, the idea on how this works with layers, you're not going to really see that clearly here unless you get really up. But this distinction, sometimes it is nice to do some stuff in 0.8 because people can really see the layering. They might understand the concept that's going on a bit better. And so there you can see it's more like a topographical map there, and they can really see it. So it might be good for that too, to show that. But if you want to do one of these, put it in a classroom, I think people are going to be fine with it. I think it's going to be nice. But I do need to clean that one thing up. So there's that. And so with that, we'll go over all the fun numbers and details. Okay, first some URLs and we'll get into this. So here is the URL for this. So I posted this. Now this is the same, in essence, file of the T-Rex double size, but for 0.8. Basically the G code's out there with the 0.8, and the 3MF files are all the 0.8. So that makes it a little more convenient to download and do it that way. But I mean, you could have done it yourself. Same files and just done. You could have done the old files, convert to 0.8 with a 0.4 layer height. Okay, and then here is the old one, just as a reference, is the regular double size that's just done, all the G code of there is a 0.4. But with that, that's it. So now let's go over all the fun numbers. So, this is a fun one. So I split this in 4 pieces. So I got 2 skulls. So the first skull piece took 15 hours and 6 minutes. It took 13.1 central electricity, and it weighs 0.61 kilograms, and at $20 per kilogram comes out to $12.20. Total in for that piece, $12.34. Now the other piece of the back of the skull, the teeth, took 9 hours and 19 minutes. It took 8.3 central electricity, and it weighs 0.342 kilograms. At $20 per kilogram comes out to $6.84. All in for that, $6.93. Now the jaw, the back part of the jaw, took 7 hours and I shouldn't say the back part, the front part, took 7 hours and 14 minutes. The teeth weighs 6.6 central electricity, and it weighs 0.25 kilograms. At $20 per kilogram comes up to $5. So all in, $5.07 for that guy. And then finally, the 2 little back pieces took 4 hours and 19 minutes to print, 3.8 central electricity, and it weighs 0.154 kilograms, and that piece is $3.08. All in, at $20 per kilogram, all in, $3.12 for that piece. So all in for this giant double-sized skull using a 0.8 nozzle at a 0.4 layer height. Takes 1 day, 11 hours, and 58 minutes to print. It takes 31.8 central electricity, and it weighs 1.356 kilograms. At $20 per kilogram comes out to $27.12 for the material. So a bit more of an expensive print. So total $27.44. So I think it's a fun one, but it's more of a pricey print that I can't see. If you look around, there's a giant T-Rex skull made that's probably the size of my desk. I don't know how much they spent on that thing. It must have been hundreds of dollars to print something that big. And of course, matters on the infill. Maybe you want to reduce the infill to lower the price. which is an interesting thing. Let's put the comparison here for if you do the other video I did recently with the double size using the 0.4 nozzle and the 0.15 layer height. That took 5 days, 19 hours, and 29 minutes. It took $1.12 of electricity, and it weighs 1.09 kilograms. And total for that is $22.93. This one, with the same infill, weighs more. In fact, it weighs what looks like about 25% more. And so it actually costs more. We're talking 27. It's about $5. I think I wrote it down here. $5.32 more to print the 0.8 with the same infill, because you're just those beads are bigger, right? So if you want to get that down, you need to do a lower infill, which I think you could probably get by with lower infill. But also the time, it prints 3.8 times faster. So you're at the same infill, you're sacrificing a little bit of weight, but you're getting more infill. You're getting more speed. So let's just call it 4 times. So although there's a little bit of cleanup to this, I think it's pretty good. I need to go do a couple more tests with it to see if I can I think I can repair it, but I would like to do what am I thinking about? A support where I had that one little problem. Then after that, I think it'll be pretty good for most people. But personally, if I'm going to make my own, if I'm going to make one for a friend, well, unless they want a bunch. If they want one, I'm going to go with the 0.15 layer height, the 0.4 nozzle, the default. If they want 5 for a classroom, I think I'm going to do the 0.8. I think the 0.8 is fine. Default's great. But when you want to go faster, you got to go faster. So anyway, sometimes there's reason to do 0.8, and this may be one of them if you want to get a lot of these out. With that, we'll wrap this up with a reminder that 3D printing is an engineering adventure that you're on. You can develop your skills and your knowledge, and you can take this in so many ways. You can make a business out of this. You can teach others, and you can make some amazing designs. So design it, engineer it. So many name tags. I was not intending to make name tags in the Printables name tag contest. I plan on becoming just a mere consumer. But although there were lots of great submissions, nothing caught my eye, so I made a bunch of them. The 2 I'm most proud of are the angel wings and the T-Rex one I made, both with magnets inside them. I figured once you really started using 3D printed name tags, it might be a little unbalanced and need a stronger base. The magnet in it and one underneath the shirt seem to have fixed that problem. It holds pretty well. Anyway, check out the awesome name tags folks have submitted.